Hello everyone, welcome back to our webinar. Today we will talk about ELISA sample handling, and we will talk about common problems that we will see during the ELISA processing, and we will show you like how can we solve them. For today's webinar, there will be two parts. The first part will be the key considerations of the sample selection and the processing, like how you choose the right sample and then how do you do the correct processing, like some key points there. And later I will show you that some common problems that you will see during the real experiment and how can we solve them. For the first sample session here, I will talk about the sample handling from 4 different perspectives, the importance of sample processing, the right sample type, and how you choose the right sample type, and then the correct sample processing method. Then the last will be the preservation and the transportation of your samples. Okay, so a very short introduction about ELISA. ELISA is a highly sensitive experimental technique. It combines the specific reaction of antigen and antibodies. It highly relied on the efficient catalytic activity of enzymes on the substrate. The advantage of ELISA, actually there are so many. ELISA is a simple and convenient operation, and the equipment that you can do the ELISA is quite simple. And also for the ELISA testing, you can do the ELISA testing like in a high throughput manner. Then the ELISA can be used for many diverse applications like the diagnosis, CMC, research, and analysis of the food and residues. Okay, so let's go back to the sample handling. Why the sample processing is so important? Because actually it's the cornerstone of the, to ensure the accuracy of your experiment and the quality of the sample. Actually directly determine the accuracy and the reproducibility of the result. If you do the sample handling improperly, I would say that there are 3 effects that you may see. The first is false positive result and false negative result, and the last is the increased experimental error. For the false positive result, usually this result can come from two, like a contamination and non-specific reaction. For contamination, we usually refer to the external agent, like the bacterial, virus, and chemicals that introduced during you collect the samples. And for non-specific reactions, it's because that the components within the sample, they may induce a non-specific interaction to the antibodies, so causing the false positive result. Then for the false negative result, they can come from 3 different parts. One is the excess dilution, analyte degradation, and the interfering substance. For the excess dilution and analyte degradation, these 2, they will make the target analyte concentration fall below the detection limit. So you see that if the concentration is below the detection limit, so you can never get a very good result. And for the interfering substance, we care about the substance that have a similar structure to the target analyte. And this substance, they can competitively bind to the antibodies, so masking the true signal, then causing the false negative result. Then the next is the increased experimental error, like the inconsistent handling and the equipment error. Inconsistent handling, they usually because the variations in the sample processing between different batches and different person. And for the equipment error, usually, there are 2 common equipment that we will use during the ELISA testing, the centrifuge and the pipette. So these 2, if they have errors there, they will definitely affect the processing consistency. So to have a summary and conclusion here is that we want to do the sample processing correctly because we want to have accuracy result and make sure that our experimental results, they are reliable and have a good credibility. For the second part, let's talk about the different sample types and how can we choose the right sample type. Selecting the appropriate sample type is important to ensure the success. And we know that there are so many different types of the biological samples that you can do the ELISA testing. Each of them has the distinct characteristics and has different application scenarios. Common sample types that we usually use during the ELISA testing will be like a serum sample, plasma sample, tissue samples, or cell culture supernatant, so something like this. And I will talk them in details, and I will say each of them have its own characteristics. So the first is the serum and the plasma sample. For this type of the sample, they are rich in various biomarkers, such as antibodies, antigens, and the cytokines. They can be used in the immunology. And for this type of the sample, we want to avoid the interference from the fibrinogen and blood lipids, because these two, they will induce the non-specific interaction. For the tissue samples, usually this type of the sample, they contain the cells, extracellular matrix, and biomolecules like the DNA or RNA proteins. They can be used in the proteomics research and also like a mechanistic studies. For the tissue samples, you don't want them to have a degradation, so be sure that you can add something to prevent it. For the third one is the cell culture supernatant. This type of sample, they contain the secreted proteins. So we usually use this type of the sample in cell biology research on cytokine detection. Because it's the supernatant, right? So we do not want to have a cell debris and dead cells inside. The next type of the sample we commonly see is the urine samples. Urine samples, the feature is that they're quite easy to correct, and also they have various metabolites and biomarkers in this sample. They are very suitable for metabolic studies, and also because they are easy to correct, and so they are easy to get contaminated. So avoid contamination will be a important thing for this type of the sample. And also, in addition to the previous four, we have some other body fluids, and there are different types like the saliva, the supraspinal fluid, fecal infusion, and acetates. So this different type of the body fluids can be used for different field of the research. This is a summary slide about the basic principle behind the selection. The first I will say is the purpose. So please select the appropriate sample type according to your research or your demand. And then next you can consider like how easy and feasible that you can correct the sample and whether the sample is easy to store. Then the last, you can consider that what is the potential cost of the sample correction, processing, and storage. So whatever, in overall, researchers should have a systematic evaluation about the characteristic of different sample types. And then based on that, all these principles, you can get high quality data. Then let's come to the third perspective about the sample processing is the correction of this type of the sample. So we talk about different type of the samples, and actually the correction method for all these type of samples can be so different. Even the serum sample and the plasma sample, for these two, they are different. So for example, for the serum samples, we usually will allow the whole blood sample to stand at room temperature for 2 hours or at 4 degrees overnight. Then you centrifuge and correct the supernatant. But for the plasma sample, it's different. Plasma sample, we need to use the anticoagulant, like EDTA or heparin. So you use these two to correct the sample, then you centrifuge the sample and then correct the supernatant. And for the tissue lysate, it's a different thing. Tissue lysate usually is a solid, the piece. So you can take 100 milligram of the tissue sample, rinse with 1x ppb to remove the blood contamination. Then for the large piece, please cut it into the small pieces and place the pieces into the tissue grinder. To homogenize the sample, use the PBS. Then you place at the -20 overnight, and we need to repeat 2 rounds of the freeze and thaw cycles to disrupt the cell membrane. Then use centrifuge and crack the supernatant. So for all these 3, if you do not want to do the testing immediately, then for the samples, please aliquot the sample and store the samples at -20 or -80. And a kind reminder here is that please avoid the repeated freeze and thaw cycles. And once you froze the sample in the freezer, after you thawing the sample, please centrifuge the sample again before you do the next ELISA testing. And then here is the sample correction for the cell lysate. For cell lysate, we know that there are 2 different types of the cells, the adherent cells and the suspension cells. For these 2, the correction can also be different. The adherent cells, we usually need to aspirate the medium, and then we wash the cells with the cold PBS and the centrifuge and correct them. For the suspension cells, the first step is to do the centrifuge first to get the pellet. Then you generally resuspend the pellet and wash the cells with the PBS, repeat the centrifuge, and then you do the freeze again and 2 rounds of the freeze thaw cycles to disrupt the membrane and then to correct them. So the same thing here. Please avoid the repeated freeze and thaw cycles. And once you thaw, please centrifuge the sample again before you do the testing. The last 3 samples that the correction method are quite easy because we just do the same, the centrifuge, and then we correct the supernatant. So, basically they are the same, but the same thing here. If you don't do the testing immediately, please aliquot the sample and then store the sample at -20 or -80. Another thing about the correction I want to remind you here is that sometimes you will see the different blood correction tubes, and the blood correction tubes actually they are recognized by different colors, like a red, yellow, gray, green. So different correction tubes actually they have a different additive. You can see that like a non-additive or different additive like the CROT activator, EDTA, something like that. This is because that for the serum and the plasma samples, the correction steps or correction methods are different. For the serum samples, the pale yellow liquid, they are separated from the whole blood after natural coagulation without the anticoagulant. But for the plasma, we need to add the anticoagulant to the whole blood and then correct the sample. For the anticoagulant, we have a 3 different things. So not only 3, but 3 common anticoagulants, the EDTA, heparin, and citrate. For these 3, the features are different. So for example, for the sodium citrate, they have a very good protective effect on the coagulation factors, but it's quite weak. And for the EDTA, this one, they can preserve the cellular component of the blood, like the blood cells, white blood cells, with the minimal morphological changes. For the heparin, the feature is that it will not affect the blood cell volume, and it's not that easy to homolyze and can withstand high temperatures. And for the tissue samples and the cell samples, we have some additional processing method here. For example, the sonication. The feature is that it has a very high lysis rate. And the chemicals we can use, like the RIP RPA, we can disrupt the protein structure by breaking the hydrogen bond, interfering the antigen and antibody interaction in ELISA. We also have the protease inhibitors to suppress the protease activity to prevent the target degradation. So we can use this one to prevent the degradation. We also have the proteinase K to degrade the proteins like the histone, viral coat proteins, and RCs. And for the cells, especially the adherent cells, we have the trypsin. So trypsin digestion can help us to detach the cells by digesting the intracellular proteins, but just be sure that you avoid the over-digestion. You can stop it when the cells recheck. For the sample processing method, we do the centrifuge a lot, and another reminder about the centrifugation here is that we know that there are two parameters that are closely related with the centrifugation, the RCF and the RPM. So RCF is the relative centrifugal force, and RPM is the revolutions per minute. There is a direct interaction between these two parameters. It relies on the radius of the loader. So this one is the distance of the particles from the center of the rotation. So with this equation, you can do a quick conversion from the RCF to the RPM. And here we also have a summary table showing you some common speed of the rotation that you can find during the centrifugation. So please check them, and if you need to do the conversion, just check this equation. Then for the first part of the webinar, so the last perspective is about the sample preservation and transportation. For this part, I would say that choose the appropriate storage temperature is very important. It's really based on your sample types, like a serum sample, plasma sample, or tissue sample. You can choose different temperatures, like a -20 degree, -80 degree, or 4 degree. And also for the samples, our recommendation is that always aliquot the samples if necessary, and you can leave the adequate headspace for the expansion. For the freezer and the refrigerators, we recommend the instrument having the temperature display and alarm functions because with this, you can regularly monitor the equipment performance. And also degradation is another thing. Ensure that your samples are stored and transported at controlled temperature to prevent the degradation. Another thing is that when you do the transportation, we want to maintain the sample integrity and stability, right? So suitable container and packaging materials will be a very good help. And then the next is contamination. Contamination usually comes from the microbial contamination, like bacterial and viruses. So cross-contamination should be avoided, during either the preservation and the transportation. And also the last two is also about transportation, like a distinct containers and the labels can help you to differentiate the sample types. And please document all the storage and the transportation conditions. This will help you to make a very good record. So the summary here. When you do the transportation, 4 things that you need to be careful: the materials, container size and insulation and labeling. And also during the transportation, temperature is very important. I would say that maintain the low temperature during the transit will largely help your samples to be safe, to be, prevent from the degradation. And the monitor of the temperature with the data loggers will help you to have a very good record. And please choose the good providers with the temperature controlled service if it's required. Yeah, it's so important. For the second part, we will talk about common problems and the solutions to help you solve the problem. So the first common problem is also about the sample processing, and the sample type is serum sample and plasma sample. So as you see in the right picture here, you will see the hemolysis, right? You see that the pink and red, so meaning that it's a mild hemolysis and a severe hemolysis. So I will say that for your samples, please avoid the hemolysis, because the hemolyzed samples, they usually have a endogenous HRP enzyme there, so it will have a similar HRP activity and non-specifically bind to the antibodies, so result in the non-specific reactions in the ELISA, so interfering with the accuracy of the result. And also, despite the red color, if you see the milky white color, it's often due to the high triglyceride. So this one will also interfere with the antibody antigen reaction, then affect the OD ratings. Contamination should be also avoided because kind of the same thing. Bacteria will have the endogenous HRP, so causing the false positive result. And also, please avoid the sodium azide in your samples. It will also inhibit the HRP activity. And the last three is the temperature, precipitate, and the freeze-thaw cycles. And we also have the degradation. So these four can also be found in the sample type, the tissue and the cells. For the degradation, one key part here is that you can add the protease inhibitor to prevent the degradation. And for some other common problem is about the storage and the precipitate. So I talk about the temperature a lot. So sometimes for the samples that you intended for the testing within 5 days, you can generally save the sample at 4 degrees. But for the storage of the testing up to 1 month, the storage temperature should be -20, and for even longer preservation, please save the samples at -80 degrees. And after you thaw in the frozen samples, so sometimes the proteins inside the samples, they will become concentrated. So in this case, please recentrifuge the sample at the 3000 RPM for 2 to 3 minutes. Then you can correct the supernatant, especially the medium and the upper layer of your sample for analysis. If you see your sample that already have a cloudy or contain the precipitate, you can generally just centrifuge first to clarify it before you do the further testing. And another common problem like the researchers usually have during their testing is the dilution. Sometimes our analyte, the concentration is too high, like they are not in the detection range of the kit. So in this case, we need to make a dilution. So here, we give you a good suggestion about how you can do the dilution. So for example, for the 1-to-10 dilution, we commonly will pipette 25 microliter of the samples into the 225 microliter of the sample diluent. Then you can mix it and use the diluted sample for testing. And from the 1 to 100 dilution, from the 100 dilution factors, then we usually will do a 2-step dilution. So meaning that you can do the 1 to 5 dilution first, and then you can use the diluted sample to do another 1 to 20 dilution. So for example, first you will do the 1 to 5 dilution, right? You can pipette 10 microliter of the original sample, then into the 40 microliter of the sample diluent. Then you mix. Then for the second round of the dilution, you will take the 50 microliter of the above diluted sample and then mix with the 285 microliter of the sample diluent. Then you mix well. So it's a 2-step dilution to make the 1 to 100 dilution. So to have this one, and it will be more accurate. So the same for the 1 to 500 dilution and 1 to 1000 dilution. Our suggestion is that if you need to do a pre-test, like a pre-experimental optimization, so sometimes like you are unsure how high is your concentration and which dilution factor you will use, we usually will suggest you do a dilution gradient. So you can choose the original 1 to 10, 1 to 100, and 1 to 1000. So from this dilution gradient range, you can find the optimal dilution factors that you can use for your experiment. Okay, so we talk so many common problems. Let's say some case studies using our CUSABIO ELISA kit. So here is a kit from CUSABIO. It's the most interleukin 1 beta kit. And we are using this kit to test the different dilution of serum samples. So as you see, we have a different serum samples. The first S1, S2, S3, S4, and 2, S7. And for each serum sample, we make a two-fold dilution, and then we use the same kit to make the detection. So as you see, for the S1 and S3, once we make a two-fold dilution, the concentration is undetectable. But for the S4, we do a two-fold dilution and we got a detectable concentration, but comparing to the original one, it doesn't look that right? So in this case, I will say that for the different dilution factors, they will definitely affect the result. And in this case, once you see the two-fold dilution doesn't work well, I will say that test the undiluted samples will be a very good choice. Okay, then the next case here is to showing you that there will be a slightly difference in the original sample and the freeze thaw samples. So the effect comes from the repeated freeze and the thawing. So we have a two CUSABIO ELISA kit here. One is the Cumin interferon gamma kit. The other one is the IL-17F ELISA kit. So for the left kit here, we use the same kit to detect the different samples. We detect the serum samples and the plasma samples. And you can see that for different samples, the readings, the result can be different. And for the right, the IL-17F ELISA kit here, we test the original samples and also the fresh samples and also the freeze thaw samples. If you take a look at the details rating here, you will find that there's a slightly decrease in the freeze thaw samples, I mean the concentration and also the ratings. And the same thing you can find with some other kit. We have the mouse interleukin 6 ELISA kit and the TNF alpha kit here. And the samples we used here is not the serum samples, is the brain tissue samples. We also test, make a comparison between the fresh samples and the freeze thaw samples. So here's the same. Use a different kit to test the same fresh sample and the same freeze thaw samples. You still see that the ratings are different. Here is a slightly decrease and here is a slightly higher. So whatever, you see the variation here, right? So the variation in the sample measurement is highly due to the freeze thaw. So we call it freeze thaw effect. So slightly different in the measured values. If you if you take out the samples from the freezer, the long storage will cause some minor effect. Here's another case about the importance of pre-experimental test. For the pre-experimental test here, we are using the tissue samples. So using our CUSABIO ELISA kit, the mouse brain derived the BDNF ELISA kit. So we use the kit to test the brain tissues, K1 and M1. So here is a kind of like showing you how important is the pre-test. And from the pre-test experiment, you can find the optimal protocol and the optimal dilution factor. So see here, for the K1 sample and M1 sample, we do the dilution factor from 0 to 1000. And our suggestion for the pre-experimental setup is that 2 strips are pretty enough. You can just use the 16 wells to do a pre-experiment test. And the dilution factors we suggested is just undiluted 10x, 100x, and 1000x. So let's take a look at the data together. You see that with dilution factor 0 and 10, we have a measurable OD and calculated concentration, and the same happened with the M1. But with the 100 and 1000, it looks like the dilution factor definitely is too high, so the result is undetectable. So meaning that once we need to perform the experiment, our optimized dilution factor should based on the dilution factor like undiluted and the 10x diluted. So by showing you this is saying that if you are just exploring the optimized protocol, so some experimental tests like this will help you a lot to, before you start a real experiment. And here is another case. So in this case, I'm just showing you how diverse is our CUSABIO ELISA kit. So like here, the left CUSABIO ELISA kit is both the interleukin 6 and the other one is the TNF-alpha. We can use the same ELISA kit to test the different samples like the brain tissue and the seahorse tissue sample, and also for the same tissue type, you can test the different indicators. So by doing this, I'm just showing you that when you choosing the ELISA kit, you can always check the serum types that's suitable for this ELISA kit. And in our product page, we always have list details there. So based on that information, to get a very good kit for your experiment. For the sample detection, the last thing I will talk is about the hook effect. So hook effect is very common in the ELISA testing. So what is hook effect? So as you see here, we have the sample with increasing dilution factor, right? But you see the OD values, it increase, then it decrease. So even though the dilution factor is increasing, the OD value increase and then decrease. So it's the cause here is that it's because the sample concentration is so high, so it caused the hook effect. In a normal situation, what do you expect to see? You expect to see that the dilution factor increase and your OD values will decrease proportionally. So no decrease, then increase. So what is hook effect? Hook effect is usually because that your analyte is at a very high concentration. So the excess analyte will saturate the capture antibody, and it will have another set of the free analyte in the assay solution. So this free analyte in the solution, it will compete with the captured analyte to bind to the detection antibodies. So because of this, it will reduce the effective binding of the detection antibodies, so resulting a lower signal despite that you have a very high analyte concentration. So a quick reminder here is that once you see that this phenomenon like is different, then be careful about the hook effect, and you will, you can kind of like take actions to avoid something like this. Okay, so the summary about today's webinar today is that we talk a lot about the sample processing. We talk about that we need to choose the right sample based on the experimental requirement, and we talk about how can we do the appropriate sample processing, and then how can we store the sample properly, like avoid contamination, and aliquoting is recommended. And we also talk about like if we see the precipitate, we need to centrifuge first and then do the testing. And we also see some preliminary, the importance of the preliminary experiment, and they are advised before you start a real one. Okay, last, please give me 7 minutes to introduce our company. So we are CUSABIO, meaning customer satisfied biological reagent. We are specialized in transmembrane protein expression and antibody screening. We have 5 different product line, except the ELISA kit, proteins, antibodies, and molecular biology product, small molecular antigens. Our products has been exported to more than 80 countries, including Europe, America, Japan, and Germany. And as you see, we have a very good cooperation with famous companies like Pfizer, Sanofi, Bayer, Zinker, Johnson & Johnson. Our products has been recognized by them, and we have a very good relationship with them. Thank you for your time today. If you want to stay connected with us, this is a linking barcode. Please scan this barcode and we can have a more communication there. So thank you so much. Thank you for your listening.